Next problem. Okay, let's set it up. 35 people, so that already tells me sample size is 35. 35 people are randomly selected and the accuracy of their wristwatches is checked with positive errors representing watches that are ahead of the current time and negative errors representing watches that are behind the current time. We use this to assume the population all watches have a mean of 0 seconds, right? So mean equals 0, that is my null hypothesis. That's my null assumption, right? The 35 values have a mean of 79. So the sample mean is 79 and a population standard deviation of sigma 247. So this is a population standard deviation. Sigma is 247 seconds. Use a 0.02 significance level to test the claim that the population of all watches has a mean of 0 seconds. Now, if it is not a mean of 0 seconds, this is two-sided. That is, mean is not equal to, so it's two-sided. So find the test statistic. Test a statistic, because you know sigma follows this formula. X bar is 79, mean mu is assumption is 0, sigma is 247 over, here square root n is square root 35. So let's calculate this value. If I can find my calculator, there you go. Okay, there is a numerator divided by a denominator. What goes in the denominator? 247 over square root 35. So that is the denominator. What goes in the numerator? 79 minus 0. So that is my test statistic. Okay. All right. Now what about the p-value? P-value, so this is a two-tailed test. So p-value is twice the probability z greater than, so not equal to, because this is positive, you would say greater than. It is the same as saying twice p-value z less than negative, the corresponding negative value. Okay. Now notice not equal is twice p-value z greater than. Had this been negative, you would have said less than. Okay. So it doesn't matter. If you are positive, you're going to the right. If you're negative, you're going to the left. And that's what you would use. Okay. I prefer going to the left with the negative because you have tables for it. You of course know how to find probability z greater than something. That's a 1 minus left. Okay. Either way is fine. Twice of this. So twice of probability z less than negative 1.90. Where did that come from? You round up for 2 digits, right? So following 9 is a 2, so I shouldn't be doing that. It's 1.89. Okay, after 9 is a 2, so no change in 9. So twice probability z less than negative 1.89. So let's get our table up. So we are looking for probability z less than negative 1.89. Negative 1.89 is the last column. Okay, 9 is the last column. Negative 1.89. 0 to 94. 0 to 94. All right. Don't forget we are multiplying by 2. So that is your p-value. Let's substitute that. 2 times 0, 294. Okay. Now, I need to compare that p-value with alpha, so I better calculate it. 2 times 0.0294. Okay, so you get 0.0588. Okay, so that's p-value. Is it less than alpha? That is 0.02. I shouldn't be checking simply less than, it should be less equal. Equal is allowed. Okay, now the question is it less equals, is this quantity less equals this? No, it is not. So you cannot, okay, no. So we do not have enough statistical evidence to reject H naught. All right, so let's put all that in. Is there sufficient? No, there is not sufficient evidence. Okay, so that's B for me. All right, so next problem I'll start on my next video. Until then, bye.